let's start with the Panama Papers. This is a news article from yesterday. So this is still pretty hot. It's happening all the time, new announcements about the Panama Papers. Iceland in particular is having an entertaining time, or not. This is the second major politician in Iceland to be replaced. This is the new guy replacing the previous president. And as you may have heard back in March, their prime minister was found out. I've got some more on the prime minister later on and some analysis of him. But this is the latest news. So things are really happening, and it's all very current at the moment. It first of all came out in March, but my own interest really got inspired in April. I was at the Graph Connect conference in London, and this lady, Marka Bra, did an amazing presentation. Really fantastic. There are quite a few YouTube videos of her presentations, including this particular one, which was the one she presented in London. And I strongly recommend you take the time, if you want, to learn more about the papers and how they're actually used to analyze from a journalist side. She represents the ICIJ, and they're a consortium of journalists. 190 journalists in more than 65 countries, only 12 permanent staff members, 50% of which are technical. And they do data journalism, analytical journalism, to discover things like financial fraud. And they are responsible for publishing this leak, although they're not the ones that first discovered it. So they started making media waves back in March, and since then there's been a whole series of publications. But all of this started about a year ago when somebody, John Doe, we'll call him, apparently contacted a German newspaper. I don't dare pronounce that. Süddeutsche Zeitung, perhaps? My German's bad. And offered to leak data. How much data? A lot, apparently. And why is he doing it? He wants to make these crimes public. So he's already implying that this data is related to criminal activity. I should state up front that just because your name is in the Panama Papers doesn't make you a criminal. There are a lot of legitimate reasons why someone might create an offshore company. But usually you're doing it to achieve some level of secrecy. And secrets can often be covering something else. I've got an example later on of something that looks completely innocent and probably is completely innocent. How big? Very, very big. 2.6 terabytes. Here is a graphical representation to give you an idea compared to the previous largest leak, which is the offshore leaks from 2013. It's 10 times bigger than that. And that in turn is very much larger than any of the other previous leaks. I mean, the Swiss leaks got very big news when it came out in 2015. WikiLeaks, one of their leaks, is very, very much smaller than that. So we've really scaled up in size. This is an insanely large amount of data. And as a result, this has not been analyzed yet. They've been working a year on it. And when they started to make announcements in March, that's only on some part of the data. They're still working on it. Part of the reason is it's quite complicated, many different types of data. The emails, as I understand, they haven't really been processed yet. So this is in process. The database formats, that's what they've worked on the most, and the database that we are going to look at today is based largely on a combination of the database formats that they've been massaging into something they'd like to release. Then there's many other things that actually require scanning, processing, and analysis. So I think we're going to see more and more information coming out over time. What we're going to talk about today is mostly what they got out of that part and released on May the 9th. This piece up here, they decided to make a public release. Instead of just doing what they'd done between March and May, which was releasing articles of their analyses and their conclusions, what they thought people had done and why, as journalists do, they have released an actual database that can be used by anyone to analyze this, to discover something interesting. And that's what we'll look at today. The first release on that date is in fact this website, and I've got a references page at the end where you can go to this website. Here you can interactively interact with the database, you can type in queries and discover things, and I'll have a few slides on that. But what's more interesting to me, and what we'll talk about today, is behind this database, behind this application is in fact Neo4j. And they made available a few weeks later a download of Neo4j with all the Panama data that they were releasing embedded in it. So you can just download that, start up the database, and start typing queries. This data was very popular. A lot of people interested in this. I guess many people looking to see if they're in the database themselves. So after only 3 weeks, so many million visitors, page views, and the top countries that they visited. There is a website that I've provided in the references worth looking at. Explore the Panama Papers key figures, and here are some of the statistics for the data. It includes the top countries where intermediates operate. An intermediate is a company that helps you set up an offshore company. So you can see where the top intermediates are. Hong Kong, United Kingdom, Switzerland. These people will help you set up an offshore company. And how many companies are started and shut down. There's a lot of interesting stuff here. And what you can do with this website is type in queries and analyze the graph structure. And a graph, in case you don't know it, we'll talk a lot more about graphs, is simply a connected network like this, a mathematical graph. It means you have objects or nodes connected to each other through relationships or edges. There's many different terms for this. And they describe the structure of the data. In this particular case, you have things like this. This is the intermediate who registered a company. And then there are these officers or people who have ownership of those. Those are the 3 main types we'll see in this database. And you can then discover things like 2 people are connected by some intermediate to some common company, things like that. But let's move on to specific examples. Getting back to Iceland, this is one of the most popular ones people like to present about because in the initial data, it wasn't clear that the Prime Minister of Iceland, who's down here, was actually connected to the offshore holding. This connection wasn't obvious. They had to deduce it later on. Instead, he shared an address with someone else, who at that point was just his girlfriend, and so it wasn't registered anywhere else. It was only the shared address that could be tracked. Now she's his wife, and when this all came out, they were married and had created common holding in a offshore company. The reason this resulted in him resigning is, in fact, that company had shares in the same banks in Iceland that went bankrupt. And the government was negotiating with those banks to decide on the bailout. So, of course, he was in a rather controversial position of being on both sides of the fence, which is not really acceptable. So he resigned. Initially, he tried to duck and dive, but ultimately, he resigned. And they replaced him immediately, back in March. Okay. As I mentioned before, I didn't want to spend too much time on the Panama Papers. I've got references at the end where you can go and watch videos and find out a lot more. Let's get into the actual technical side of it. This is a partial view of the data model. There are 4 main types of objects here. An officer is a person, some actual human. So if you're in the database, that's what you will be. An intermediary is normally a legal company that helps set up offshore holdings. An entity is the offshore holding, and all of them can have addresses. So that officer has a registered address, registered address, registered address. This graph that we're showing you here is not a sample of the database. It is a meta model. It is a kind of like a schema, but it's not a schema in the sense that in a relational database, a schema will enforce things. If this was a schema, it would imply that intermediaries need to have registered addresses, but they don't. The data in this database is quite messy because it has been collected from many different databases and slowly over time massaged and cleaned up. I have some examples where I show how we can clean it up ourselves. For example, the fact that an intermediary should have a link to an address node is not always enforced. Sometimes there is data on this node containing an address. We can clean that up. We can extract that and create the graph in order to make our queries simpler.
That's very clean, what you have there, I would say.
Yeah, it's a surprisingly simple model, but just like with, if you look at a social network where you just have people and their relationships to other people, you can have an enormously complex network on an even simpler model. So this network can get extremely complex if you look at second and third and fourth degree relationships. Yes. Yes. I'll show that in the demo. If you don't use the sampling, you get a much more complicated one. The one I showed. That is the full meta model. Yeah.
I retract what I said.
All it really means is that there's many, many different types of relationships between these objects. So the fact that a company, an offshore company, an intermediary, they can be related by custodian of, authorized person, signatory of, auditor of, officer of. What is the relationship? That could have been structured differently.
Is that what you call edges?
Yes. Well, in Neo4j, we normally call them relationships, but they're the same as edges. Some other graph databases will use the term edge, which is closer to the mathematics of graph theory. Cypher. So this is what I like, and this is what I would like to do the demos on. Cypher is the query language that Neo4j uses to query the database. I believe it's very easy to use. I'm used to it, so I may not have an objective viewpoint on that, but I'm going to show you some Cypher. I don't want to spend too much time explaining everything about Cypher. I'll build it up in a few simple steps and then just simply throw examples out. If you have any questions about some part of a query, just ask and I can clarify. So starting with that meta model, I can guess that it's possible to express this pattern expression here. What this expression is saying is I expect address node to be connected to officer nodes, to be connected to entities, to connected to intermediaries, connected to addresses. And I can see that that whole chain can exist up here. You can go from address to officer to intermediary to entity, or you can follow that whole pattern there. But it doesn't mean you're going to find anything. Depends on how you anchor it. If you're looking for a particular person, if I put a name on this and say, I just want this person, that person may not have an address and then you won't find anything. So you need to decide how restrictive you want to be in your pattern expression. If we evolve this into Cypher, you have the choice of also splitting it into multiple lines, where you tie this using a variable. So I say, I'm looking for addresses connected to officer, connected to entity. That entity E, I also expect it to be connected to intermediary, address, and the entity should also have an address. I've added an extra restriction than the one we had at the bottom. There's now 3 addresses here. Then I don't want to find every single case. If I asked that query on the database, I could get hundreds of thousands or millions of patterns that match that. Usually that's not what you're after. Normally you're after something more specific. Like, I expect the person name to be Emma Watson. Why did I use that example? I mentioned before there are sometimes, there are many valid cases for why you want an offshore company, why you want the secrecy of an offshore company. In the case of Emma Watson, if you read the articles on this, she is chased by paparazzi. She wants to buy a new house. She doesn't want everyone to know where it is. So she registers an offshore company and buys a house with an offshore company so the records don't show her name on the company, on the house, on the land. So that helps her achieve some privacy. So that was a useful thing. And she used Mossack Fonseca, the company in Panama that had all this data, to help her set that up. Here's another example. Oh, I think you'll recognize this. This time I'm looking for Gunnlaugsson. That's the Prime Minister of Iceland again. And if you ask for a path that says, I expect Gunnlaugson to have an address that is shared with somebody else, as I mentioned, his wife-to-be, his girlfriend, who in turn owns some offshore company that is set up by some intermediary. So this is the question we're asking here. It's quite a complex question. If you were to ask this in SQL, it would be 1, 2, 3, 4 joins, and the query would be, I don't know, at least 6 lines long. So it is quite a lot more convenient in Cypher. So that question just says, find me this pattern where Gunnlaugson is the officer. And this is the result that we see. So I want to switch over to the demo, and I will do that query. I've got a couple of other queries to show you before that particular one. I'm not going to explain this one, I'll just show it to you because it's nice to see. All right, there's a simple query that counts how many registered addresses occur in each country. And this is both offshore holdings as well as the intermediaries as well as the offices. Any registered address, I just want to know where they are. And we can see that China and Hong Kong have a lot. We haven't spent much time looking into China and Hong Kong, why that is, but it's quite interesting. Obviously, they do a lot, especially, I guess it's between China and Hong Kong. What I've done in addition to this, something that's not in this database when you download it, are geocoded addresses. A geocode address means you take something like the street name and number and postal code and try to find where in latitude and longitude on the Earth that actually is. And there are services on the internet that can help you do this. In the demos here, I will show how to do this with Google service, but we've got access to a few other services. And the database, as downloaded from Panama, includes a sample of the extensions needed to actually enable this. What I've done here is I've run the geocodes on several countries, and these are the ones that actually succeeded. So in the West, we find quite a high success rate. Most of the addresses that are in this database can be found by Google. Some countries have a rather low success rate. It's not too bad here. Indonesia, not that great. Oh, here's a bad one. Jersey. Why would Jersey in the UK have a very low geocoding rate? I can tell you the answer. I thought maybe you might guess. So, post boxes. These addresses don't actually have locations. So Jersey really is a hot spot for offshore companies that don't actually have a real location. They're only post boxes. There's one thing I want to show you first before this, before we carry on with queries here, and that is downloading the Panama Papers. Oh, I don't have internet. Okay. The last slide, I've got some references which you can look at later, and that will show you how to download the Panama Papers. And what you get is a TGZ file, a zip file like this, which you can extract. And you have two choices now. One is, it's got a README in it that tells you how to get it started, and then you can start to interact with it. There's another choice which I prefer, and that's what I've done with this demo, is I've simply copied the database into my own installation of Neo4j. That allows me to add more features to the database, add extensions and things like that, which is quite powerful. So inside this archive, there's your README, but you also have the database inside here. There it is. You want to copy that down into your Neo4j installation. I've copied it over there. Then, of course, you need to make a small edit to the config file. I don't want to show you that. It's just 1 or 2 settings to enable some extensions and the Google Geocoding API. And then you will have access to everything. We can go back to the demo. The original download there is 2 216 megabytes. So it's obviously very much smaller than the 2.6 terabytes.
But that's zipped, or?
Yes, gzipped. Just the database part of it here is 140 megabytes. One of my demos will require internet access, so if we do that one after the pizza break, then I'll talk to Michael and get internet access so we can actually show that demo. It's quite a nice one. All right, on with the demo. I want to show the geocoding I mentioned, how to take an address and actually get a location on it so you can do more advanced stuff with it. This query over here, I say that I want to find all addresses where the country code is Switzerland. So how can geocode Switzerland? In fact, let's do one on something that doesn't have too many addresses. It won't take too long. Any countries of interest? So I've done Sweden already, sorry. I haven't done Norway. Where is Norway? I think it had like less than 100. There's Norway, 97. Norway's not been done. So let's do Norway. All right. So find all addresses in Norway that have actually got an address property. This is a schema list database. There's no enforcement that every one of these address nodes will have this address property, so you need to check for it. And I keep a marker flag here just to remind myself that it's been geocoded. I don't want to repeatedly attempt to geocode things that have already been geocoded unsuccessfully. So the first thing I do is I set that marker flag so that I don't make the mistake of re-geocoding it. Then I'm going to call this. Now this requires a little bit more explanation. Neo4j itself doesn't understand the concept of geocoding. That's a domain-specific or application-specific thing. However, you can install extensions that will provide you with additional capabilities. What I've installed in this database is APOC, which Michael Hunger wrote a few months ago. It's a wide collection of just tons of utilities, a lot of things there, including that metagraph that we showed earlier on. That comes from APOC. And APOC includes the geocode ability. I've also installed an extension for the spatial, the stuff I worked on many years ago, which maybe we get a chance to look at. So what we're doing here is we're saying, I just want to geocode the address. Maybe I should increase the font size so you can see. Oops. All right. Geocode the address. That will return a location. I'm going to store the location on that same node as latitude and longitude, and then just count how many times that was successful. This is using the Google Geocoding API, which is pretty quick, so I think 10 seconds or so. Oh. Well, there was no surprise. No internet access. I do this for blocks. That limit, together with assigning this true, means that the next time you run this, it will skip over the ones you've already geocoded. Sorry, there we go. And not geocoded. So if we run this once, if you have, say, 10,000 addresses, you run it once, it'll do 1,000 and mark those 1,000 as true. Then you run it again, it'll then do the next 1,000. This is a nice way of paging it or batching it, because all of them will be done in one transaction. If there's a failure, everything's lost, because the transaction will be rewound, Neo4j being a fully transactional database. So that's a good policy. In the earlier versions of geocode, if Google rejects it, then it exited with an error. So it's good to batch it like this so you can avoid bad addresses that Google can't cope with. In the case of Norway, there were only 97, so it wouldn't hit this limit at all. So let's find Emma Watson. Let's get back onto the part that was in the presentation. So I'm going to look for that path, an address for a person that has an offshore company set up by an intermediary. That's what the path says up there, where the person is Emma Watson. There we go. What we can see here, Emma Watson is a shareholder of Falling Leaves Limited. That was set up by Mossack Fonseca in the UK. I mentioned Mossack Fonseca before because that's the company in Panama that where the leak happened. So that's there's a lot of Mossack Fonseca in this database. We can double-click on nodes here to discover if there's anything else of interest here. And here we see that there is another Emma Watson, Emma Charlotte Duer Watson. It turns out that is her real name, so she's in this database twice, and we know that we could actually connect them together. That Emma Watson has got a different address than the first Emma Watson. And these addresses, if I click on one and click down here, you can see they've been geocoded, latitude and longitude. So they have been found in the Google database. So not a lot of exciting stuff here. It's just that Mossack Fonseca set up Falling Leaves for Emma Watson and Emma Watson.
Can you do fuzzy searches?
It depends what you mean by fuzzy, because
Well, if Emma has two S's in Watson.
okay, no. You would then need to do contains. You would need to say contains Watson with one S or contains Watson with two S's. So you'd have to do it as a composite thing there. There are regular expression matches here as well. So if you know regular expressions, you could use that.
Question: Can you go from this to the raw data? Let's say that you have a lot of databases and a lot of emails that you want to, okay, which email, because maybe the address, but there was more information that you want to read from the original raw data.
Yeah, the problem is the database they provided in the original CSV downloads or the Neo4j version is just what they provided. They haven't provided the 2.6 terabytes. And we hope, of course, over time they will provide more and more and more.
There's no reference to it.
No. So this is the raw data as raw as they've released it. Anything that's not in here has not been released publicly. Here's a related query, find location of falling leaves. So in this case, I'm looking for a slightly simpler pattern. Officer entity intermediary, where it's Emma Watson, and the intermediary has an address. So not Emma Watson's address, but the intermediary's address. Then I noticed that if we go back to this graph from the previous query here, there is no address node if I double click on this. Wow. Okay. There was no address node. What double clicking has done has shown us that Mossack Fonseca has set up quite a few other companies. At least this is only the UK branch, right? There's a lot more in the other branches. So, yeah. The main problem was that Mossack Fonseca, that node itself, did not have an address node, but it does have an address property. I mentioned this before. If I want to geocode that address, it will fail because it includes the first part, limited. I'll show you an example of that actually. Let's type a query in here. I'm dying without internet access here. This is terrible. All right. The geocoding won't work, but the example I wanted to show you, I'll explain the query at least.
The double clicking you did on some node here,
Mm-hmm.
you can do that in anyone here?
Yes.
So you double click Arcstone, that will be something.
Well, if you want to see that, we're just going to make this graph a lot more cluttered. Let's shrink this a little bit. So pick something and double click it. Oh, that one's got nothing. There we go.
Which is in general, you move to that node and see all the connections to that
Yes. So you can continue to explore this graph quite a bit by just clicking. Oh, there we go. This is interesting. Here's the same address for several different companies. So again, these are offshore companies that are made as postbox companies. They're not real companies. They're holding companies, or they're just there to perform some purpose. So the fact that they have the same address is not at all surprising.
Is that native Neo4j?
Yes, yes, yes. Everything you see here is Neo4j. So and if you see that phrase call, the call geocode, that's an extension. If the word call is there, then it's not built in, but it's easy to add. Let's go back to which one was it? So this particular query, the intention here, and this works if you have internet access, of course, split the address with that word limited. The address happened to have the company name limited plus a real address that could be geocoded. If I split it on that, I can take the last field and geocode it. And that'll create a location, which I just return. I could also, instead of simply returning it, create a new address node, put it to that, make a connection back to the company, and repair the graph. And that's something that you could also run on bulk. You could say, find all companies that don't have address nodes, but do have address fields, geocode them, get the results, make the address nodes, and connect it up. So let's get on to the Iceland example. It's a nice one. And if you compare that graph, let's make it a bit bigger, to the presentation, you'll see there's a difference. In the presentation, this company has an address, and here it does not. And that's because this is exactly that case, where the address is inside the node. So what I did when making the presentation is I went through that process. I geocoded it and I made the node and connected it up. But as we've seen, without internet, I won't be able to demonstrate exactly that, unfortunately. That's the fix address.
We believe you.
You believe me. That's good. There it is. Well, the top part's the same. So from the point where I geocoded, I get the location out, and then this merge statement means create a new relationship to a new node, which I'm going to call win, and on that I'm going to store the location, and then just return it so we can see the results. So it's relatively straightforward.
When it comes to data cleansing, there are other programs that can do cleansing for you.
Yeah.
Has that been used here?
The ICIJ have got their own process for the way they've done it. They have many, many different tools they've been using, and I think there are some presentations that explain the details of that. But my presentation is about Cypher. And Cypher can be used for quite a bit of data cleansing. This is just one example.
But in the address, you store the whole address. You don't split by street address, zip code.
Yeah, that's because with this example, when I sent it to Google, they geocoded it quite happily. But I think if we look at that address, it wasn't that. Yeah, it does have the company name, Luxembourg International Consulting SA, so this part's the company, and then there's the address. I passed the whole field to Google, and it was happy. When I did the same thing to Emma Watson's company, it said, no, can't find it. Then I cut off the company name and sent it, and it was happy. So that's an artifact of Google's geocoding. What I've tried over here are 3 different geocoders, Google, OpenCage, and OpenStreetMap. And all 3 of them gave different results. Sometimes they gave different actual locations of an address, but normally it would be, say, the center of the building versus on the street or the entrance of the house. So they have subtle ideas. Hi, Emil.
Hi, Craig.
Good timing. Yeah. You missed all the stuff that worked. Now we're on to the stuff that doesn't work. Michael left and I don't have internet access. But I'm explaining Cypher without it. Yep. Great. Let's try that. Is it this one, public? No? But then it doesn't need a password, does it? This one here? All right.
This one is public. The one I gave to you with the password is the one down.
Somewhere in the middle. That one? Right, let's try this. See, it's very. Hmm?
I didn't have it. There is an app. It's like Panama Papers.
So, where's our first geocode? Let's go back to this. Well, I was going to show you just a simple geocoding. If we grab that address, we can actually type it in here. Right, we don't need the yield if we write it just simply like that. And sorry, I missed a piece. There we go. There we go. So the data that gets out of the geocode, we've got two blocks, a location, which we've standardized for all geocoding services, latitude, longitude, and some description. This is what the geocoding service thinks the address should be. So it's a reverse geocoding. It'll geocode from the address you give it to location and then back to its own understanding of the address. Then there's an additional block of data that the geocoding services give you. Google will give you one set, and if you use OpenStreetMap or OpenCage or the other ones I've tried, you get different information here. We provide it in case you want something there. It can be quite nice if you want to access like the regions, Luxembourg or whatever, and you want to categorize based on the location. There's quite a bit of information here, as you see. So let's try that find location for falling leaves. Emma Watson's company. Should now work. There you go. So that's where falling leaves is. And I see that we're getting closer to 6:30, so I think there's a point we could break. I'd like maybe another 10 minutes, then there's a good point to break at. Then I've got two other demos that are entirely optional for after pizza. So let's see if we can get through a few of the things here. We won't go and fix that Wintris address. Let's move on to the one you asked a question about. How do you analyze the structure of the graph? This is a very nice way of finding out more about it. And I can remove this unnecessary node there. There we go. So now you can see a little bit about that. We've already talked about that, so I'll just show you the complex version to take away the sampling and to ask it to tell us everything. There we go. So if you really want to know everything, as you can see, there is a lot to know. Everything has an address. I'm going to just take the address away and show the other main pieces. There we go. Everything connected to everything. And the most detail is between an offshore company and the person that actually has the holdings in that company. Very, very detailed. So I've got a series of interesting queries here that are more Panama Papers specific, that we can just go through quite quickly. Here's a query to ask for offshore jurisdictions by intermediary. Have a look at the results and you see what that gives. So these are where intermediaries are. We can see that companies that are engaged in setting up offshore entities are mostly in the British Virgin Islands and second most in Panama. If you go back to that stats website on Panama Papers website that I showed you before, they actually show you how these numbers change over time. And this number, Panama, only started to ramp up in 2004 or 5 because of changes in the law that made it harder to set up companies using the British Virgin Islands. So you can see everything changing over time, which is very, very nice. That you can't see here. Here you see the current count. So this is still large because historically it's been used a lot, but it's been dying for the last decade because of legal changes. And the laws are changing all the time, and that has a very dynamic effect on these results. How about this one? The most popular offshore jurisdictions for people connected to the United States. So if you're in the US, where do you like to work? Cook Islands, Samoa, Bahamas, Cayman, Seychelles. Yeah, sound like nice places actually. Let's look at a particular city. Most popular offshore jurisdictions for people with addresses in San Francisco. We can type in any city there. So people in San Francisco also want to work with British Virgin Islands. This is, of course, an artifact of the fact that this is Mossack Fonseca data, and Mossack Fonseca worked a lot with the British Virgin Islands. It may not be true, globally speaking, with all offshore companies, but this database shows it like that. If you want after pizza to query certain other cities, we can go and just change the city name on those. Here's another one. Now that one we've done.
Can you show the whole query?
Do you want to see that? Okay.
Let's escape, I think. Oh, it's not so big.
No, it's not too bad. Shall I explain this query then? It's not so bad. I'm just saying I want a city called San Francisco, a state, California, and I'm looking for this pattern, an address, a person, this is an actual person, right, who has a registered address where that person also owns some offshore holding that was set up by an intermediary, and the address contains San Francisco and the address contains California. Then I'm going to return the intermediary and the count of the people. There. So this is really by intermediary. So this is not where people set up their offshore holdings. This is where the legal firms are that do the work for them. Sorry. Yeah. 2 dashes is just leaving out this bracketed part. So it simply means that we want some relationship. We don't care what type of relationship it is. Whereas here we're saying the relationship between these two must be intermediary of. You're asking for that very specific thing. So you're just being more restrictive in your query by saying that. And the directions are important. These relationships are directed. I think I've got one more of these types of Panama queries before I have a whole bunch of queries related to spatial stuff, maps and distance locations, ability to ask for things within a distance of something else, calculating distance. And those I think we'll take after the pizza. So let's just do this one. Did I run that?
When you run this, do you have some kind of library of queries where you do some small
Yes.
modifications? When you
Yes.
work with it?
This list here, I simply copied the query into the field, and you click star, and it'll store it on the left so you can remember it later on. When I first set up this demo, I was intending to sit and type everything out by hand to explain it in more detail, and I realized we would be here all night. I'd like to do that, but it's far too verbose, and this is not a Cypher tutorial. It's just to show you what's possible. So that query, let's show you what that one did. This is very similar. Most popularly, it looks like the same thing actually. So I think we've done this one. Yeah. So I see Michael's not here yet. What we could do is just carry on with a few additional queries until the pizza arrives. Because what I've got after this, there's two demos. Some queries that I've got right here, which are spatial queries that search for things within certain distance. But there's another demo which I think is more exciting. And this one, you just make it a bit smaller so we can actually see it. I'm sure you've seen this one, Emil, right? You haven't? This is the field team. They set this up. Yeah. So Neo Technology has a field team that goes out and helps with sales process. This demo, using the Panama Papers, was designed to try to show the use of Neo4j for financial customers. But it's really just a generic demo on the Panama data. And it has, on this map, two queries. One is just showing where intermediaries are. You see the red dots? So you can see that quite a few intermediaries are located, well, we already saw from that list that I made, China and Hong Kong are very large. But what it also shows is where those intermediaries set up offshore holdings. So you can see the intermediaries in the UK are setting up offshore companies everywhere. So that's quite amazing. Whereas other places like Panama, intermediaries in Panama are a bit more limited to where they set it up. And if you look at something like, let's say, Australia, this is probably an artifact of the fact that Australians are investing in China and France. It doesn't mean that these are offshore holdings for the purpose of hiding anything. These are probably legitimate reasons for one company trying to make a subsidiary somewhere else. Whereas I would, a bit surprised about some of the others. So this demo also has I think it was, I can't remember what the other one was here. It has the ability to do shortest path queries. A shortest path query is simply asking, given two nodes somewhere in the graph, find the routes throughout the network to those two nodes. We can also write that in Cypher and ask for the shortest path between Emma Watson and Gunnlaugson. See if we find anything. But there are a few other possible queries that this demo has been set up. But one thing that's nice about this, it shows that you can build a very simple web application, not using Neo4j's own user interface, but this is a general purpose web application using architecture. It explains it over here. Neo4j. They also source open corporates for additional information. That's another public domain database. And on the front end, just Angular and Sigma, and you're done. And the code is even available in some sites. So it's a nice example of what's possible if you want to build an application that performs some kind of analysis. So I could do more of this, but I actually think you guys are hungry. So we have pizza, and after pizza, if you're interested, we can do some more demos of the spatial distance calculations and looking for proximity searches, things like that. So it's a good point to break.